Good morning, grade 9s. Today we're going to wrap up our last lesson on solving linear inequalities, and we're going to do it by using multiplication and division. So we told you before when we first started that solving an inequality was the same as solving an equation, except for one change that we had to do. And this is the change we have right now. So in order for you to discover it, I'd like you to go through this, and I'd like you to take and do these signs. Or help you with the first one. 24 times 3 is 72. 6 times 3 is 18. 72 is greater than 18. I'd like you to pause the recording and finish off the last 5 here. Okay, so now you should have noticed something took place when you did this. 24 times 2 is 48. 6 times 2 is 12, so the 48 is still larger. 24 times 1 is 24, and 6 times 1 is 6, so 24 is still larger. Now, when you multiply by the negative, 24 times negative 1 becomes negative 24, and 6 times negative 1 is negative 6, so we have a switch here. The sign has changed directions. Now, this here is larger than that. To understand that, we're just going to go down here for a second, down below. Here is the 24 that we were talking about a moment ago, negative 24. And here is the negative 6 right here. So this is a typical number line. It's using just the negative side of the numbers. And you can see as I go to the left here, I'm increasing by negative 3 each time. So 0, negative 3, negative 6, negative 9. Now, the thing you have to understand is as you go this direction, the numbers decrease in the amount that they have. As you go to the right, they increase. Now, that means that this side here is larger than this side as you go this way. So negative 24 is smaller than negative 6. Now, to go back to how the negatives and the positives works, an integer has two parts. It has a sign and it has a value. This is called the magnitude. This says it's on the negative side of the 0 and it's 6 units away. So it's like 1, 2, 3, 4, 5, 6 units, and it's on the negative side of the 0. This one over here is 24 units away from the 0 on the negative side. As you go this direction, the number's value decreases even though it looks like the number's getting bigger. It's this little negative sign here that messes things up, right? This side is smaller. This side is larger. As you go this way, they increase. As you go this way, they decrease. So the moment we introduce the negative number, and we had negative 1 times 24 and negative 1 times 6, this was now smaller than this. When it was 1, it was the other way around. Let's go back up here now. So negative 24 times negative 2, that's negative 48. And 6 times negative 2 is negative 12. So 48 negative is further to the left than this one is, so that makes it smaller. Negative 3 times 24 is negative 72. 6 times 3 is 18 with a negative. That means, again, this here is smaller. So look what happened here. As we multiplied by positives, the sign just stayed the way it was. The moment we switched to a negative, the sign reversed. It changed its direction. Now, let's go see what happens for dividing. So I'd like you to take and pause the recording and I'd like you to do these 6 little exercises here. So pause the recording and do that now. Okay, well, 24 divided by 3 is 8. 6 divided by 3 is 2. Means this side here is greater than that side there. 24 divided by 2 is 12. 6 divided by 2 is 3. 12 is greater than 3, so should be opening the Pac-Man. Our alligator is going to eat the bigger number, which is over here. 24 divided by 1 is 24. 6 divided by 1 is 6, so this one over here is still larger. Negative 1 times 24 gives you negative 24. And 6 divided by negative 1 is negative 6. Remember, a positive divided by a negative is a negative. So we now have negative 24 here versus negative 6. So down here, here's our negative 24, here's our negative 6. Now this negative 6 is larger, so we have to change the direction of our sign. 24 divided by 2 is is 12, and a positive divided by negative is negative. So this is a negative 12. This is a negative 3. This is bigger. 24 divided by negative 3 is negative 8, and 6 divided by negative 3 is negative 2. Again, this side is larger. So in both cases, when we introduce the multiplication or the division of a negative number, the sign here, the inequality, reversed direction. So here is your thing. The sign must change in order for the expression to remain correct if you are dividing or multiplying by a negative. Now this is the part where it becomes really, really important for you to understand. Okay, you must be multiplying or dividing by a negative in order to change. Right? You can't. It won't change if you're not multiplying. Like for example, if you had say negative. Sorry, let's get off this pencil here. If you had negative 4 times negative 6, that is multiplying by a negative. That means that's got to change. But negative 4 times positive 6, we're not multiplying by a negative. We're multiplying by a positive. So this sign now does not change. So this is critical for you to understand. Just because there's a negative here that you start with, it doesn't have anything to do with the sign. The only time that this sign changes is when this happens right here, when you're multiplying by negative 6, or if you were to be dividing by a negative. In fact, if you look here, in all cases here, these are positive. All right, and the change is happening there. These are still positive. So it's only when you introduce this negative side here that the sign changed. So this leads us to the rule, and here's your rule right here. When each side of an inequality is multiplied or divided by the same positive number, the resulting inequality is still the truth, and you do not change the sign. Maybe I should put that in there so you can just get it right here. Let's make that a little bit bigger. You do not change the sign. Right? Right there. Now look at the second line. When each side of an inequality is multiplied or divided by the same negative number, the inequality sign must be reversed, okay, in order for it to remain true. This must be reversed. There's no change. There's no other choice. If you don't reverse the inequality sign, then what happens is you've just introduced a mega error, and everything will be wrong. Okay, so let's see if you can understand the when and when not to. I want you to go down through these, and you're going to see a yes, no on your right-hand side. And I want you to go and tell me whether or not when you do the next multiply or divide in these questions here, would you have to change the actual inequality sign. So pause the recording and go through and do A to G. All right. Well, to undo a multiply by 2, we divide by a positive 2. Now remember, the rule is you have to divide by a negative in order to have anything be a problem, right? We are dividing by a positive 2. So this situation here, no, you don't change the sign. 2x, when this is gone, you had 5 each side, but then you have 2x here, you're going to divide by positive 2. Divided by positive 2 is not a problem. Now, here is something you have to take a look at. I'm just going to grab a smaller line here. All right. This is a negative 1x. Okay. So when I subtract 5 from both sides, all right, I'm going to end up with a negative 1x is greater than negative 2. Now, to get rid of the negative 1x, I've got to divide by negative 1. And divide that by negative 1. So in this case, because I divided by negative 1, the sign does change. Okay, let's take a look at this one here. Take a look, it's a negative 2. So in order to get rid of the negative 2, you got to divide by negative 2. So do you change the sign on this one? Yes, you do. This is an x, right? And when you try to get rid of the negative 2, you're divided by negative 2 here, so what you have to do is multiply by negative 2. So whenever you multiply or divide by negative 2, right over here, multiply or divide by negative 2, then you have to switch the sign. So this is also a yes. Sorry, that should be a yes. I don't know if I can make that change. It's a yes, because you're going to be multiplying by a negative 2 here. All right? So that's a mistake. All right, looking at this one here. Now, when you come into a situation where the negatives above is, this here, if you can think back to a long time ago, what we did is we said that you can put a negative with the x to the 3 or x to the 3 or in front. And when we did this is what we did. Remember, I did 1 over 4. I did negative 1 over 4. And I did 1 over negative 4. Now you'll notice that in this case, the negative is with the 1. Here it's out front, and here it's at the bottom. So this negative can go anywhere it wants. You can put it with the x, or you can put it with a negative down here, make this a negative 3. And the reason you can do that is when you divide this, 1 divided by 4 is 0. It's a 0.25. All right? Negative divided by positive is a negative. 1 divided by 4 is 0.25. Right? And they just say here, whatever it is, it's a negative. Right? 1 divided by 4 is 0.25. And of course, a positive divided by negative, the signs are different, so that makes it a negative. So if you notice, every single one of these answers, these quotients, are exactly the same. Now, the negative happens to be in different locations. Now, what this shows us is that it doesn't matter where that negative starts. As long as it stays here, here, or here, you haven't changed the final value. So looking over here, I've got minus x over 3. What I would do in this situation here is I would probably change it to be 5 plus x over negative 3 is less than 34. Then I would deal with the 5 by taking away 5 from each side. And whatever I do to one side, I've got to do to the other. So this becomes 0 plus x over negative 3. And this less than 29. All right, so now I've got x over negative 3, and I've got it's less than 29. To get rid of this negative 3, I'm going to multiply by negative 3. Whatever I do there, I've got to do over here too. There's your negative 3 here. This cancels, leaving me with x is 29 times 3, and that would be, I think it's 73 times 9 is 27, carry the 2, 3 times 6, that's 87, and of course a positive times a negative is a negative. All right, oh, and this is divided by a negative here, so the sign has to change direction. Oops, I just did it the same way. So when you look up at our question here, do you change the direction of the sign? And the answer to that is, yes, you do. Okay, add 3 to both sides. This becomes 3.4. Then to get rid of the negative 2.3, I've got to divide by a negative 2.3. Now, the moment I divide it by a negative, that means I have to change the sign. So I hope you're understanding what's going on here, all right, and how it's easier to work with. The only thing you have to do is really just know this stuff right, this little part right here. Divide or multiply by negative, that equals changing the sign. Okay? Change. Okay, now I want to see you do some algebra. So I want you to take, here's a simple one-step equation, and we're going to solve this inequality, so pause the recording, and solve this. All right, well, let's see what we've got. If I'm multiplying by negative 3, that means I've got to divide by negative 3. Whatever I do to one side, I've got to do to the other. Now, I haven't divided yet. I'm showing you what I'm going to do here. Now, once I do the dividing, negative 3 times negative 3, giving me my 1x, now I change my sign because I divided by a negative. So 9 divided by negative 3 is negative 3, and of course 1x is simply x. So x is greater than negative 3. All right? So pause the recording and try this one. Let's take a look. 4a is greater than negative 28. So 4a, I'm going to have to divide by 4 because I'm multiplying by 4, and I want to undo that. So the inverse operation, or the opposite, is divide by 4. 4 divided by 4 is 1. 28 divided by 4 is negative 7. Now, the sign does not change, and the reason for that is I did not multiply or divide by a negative. I divided by a positive. So because it's a positive, you don't change your sign. We still have a is less than negative 7. So why did we not change the direction of this inequality sign? Because we did not divide by a negative. We divided by a positive. Okay, try this one. Pause the recording and do x over negative 4 is less than 0.2. All right, so in order to undo a divide, I've got to do a multiply. And since I'm divided by negative 4, here I multiply by negative 4, and this becomes 1x. And because I have divided by a negative 4, my sign changes direction. So my solution becomes x is greater than negative 0.8. So every number greater than negative 0.8 is going to be part of this solution. Okay, so much for the one-step equations. Why don't you pause the recording and do this two-step equation. Inequality, sorry. All right, remember we always get rid of the added or subtracted component first, so I've got to get rid of the plus 7. To undo a plus 7, I have to subtract a 7. 7 take away 7, and 11 take away 7. 7 take away 7 is 0, and 11 take away 7 is 4. The 0 just goes away, leaving me with f over 2 is less than or equal to 4. Now I'm dividing by 2, so to undo divide by 2, I've got to do the opposite, which is multiply by 2. 2 divided by 2 is 1. 4 times 2 over here is 8. So this multiply both sides by 2. Multiply this side by 2, multiply that by 2. These cancel here. Leave me just with a 1, and this becomes a positive 8. So there's no changing the sign here because we did not divide by a negative or multiply by a negative. So the sign stays the same way as we got it in the original inequality. Okay, so now let's take a look and do the big one with decimals here. So pause the recording and try this one. Okay, now remember what I told you. Try to keep the variables positive. Okay, so my first step is I'm going to get rid of the added part, the 14.6 here first. We'll deal with the variables second. So 14.6, take away 14.6. I subtracted 14.6 on this side. I take away 14.6 on that side. So that leaves me with 2.6a plus 0 is less than negative 19.8 plus 1.8a. Now I'm going to take and get rid of the 1.8a. I'm going to subtract 1.8a from both sides. So there's 2.6a. Take away the 1.8a, and over here, 1.8a minus 1.8a, that gives me 0. So the 0 goes away, leaving me with the inequality of 0.8a is less than negative 19.8. I'm multiplying by 0.8, so to undo that, I've got to divide by 0.8. Whatever I do to one side, I've got to do to the other. So this becomes 1. And 19.8 divided by 0.8 is 24.75, and a negative divided by a positive is a negative. All right, so that should be a negative there. Of course, my final answer is A is less than negative 24.75. That's a negative. I'll have to make sure I change that when I do the notes. Okay, so that's that one. Let's go to the next page. Okay, so here's our next example. In this example, I don't want you to get rid of the fractions. I want you to use your fraction calculator, because in the achievement test, you're going to be doing that with a fraction calculator. So I'd like you to use it and solve this equation. So pause the recording using your fraction calculator. I want you to solve this. All right, well, first thing I'm going to do is get rid of the subtract 3/4, and I'm going to do that by adding 3/4 to each side. Now if you look right here, this is a negative 3/4. I put the negative 3/4 with the positive 3/4, and this is going to go away and make a 0. Right? Now 5/9 plus 3/4, we can do that on your calculator, and you'll get 1 and 11/36. You might also have had 47/36 if you kept it in proper form. So getting rid of the 0, we're now down to here. Now I need to get rid of the 5/6 x and the x over 3. And to do that, I'm going to subtract 5/6 from both sides. Okay. Now when I do that, this becomes 0. And over on the right-hand side, I end up with negative 1/2 over 2x greater than or equal to 1 and 1136 plus 0. So this is where I'm now at that. So I've got to get rid of the negative 1/2. To get rid of negative 1/2 times x, all I've got to do is divide by negative 1/2 by, divide by negative 1/2. Or you can look at it this way. 1/2 times 2, this is 2 over 1. And you notice that that is a reciprocal to this and this. Because these are reciprocals, that means that they're going to multiply and they're going to give you a positive 1. So I have 1x is less than or equal to, and of course over here I get 2 and 11/18. Alright, so final one, x is less than or equal to negative 2 and 11/18. Now, this is a really good point that I want to make here. You saw how I solved this. At the beginning, you are faced with some choices. All right. If you take a look up here, these are the choices you could have done. I chose to get rid of the 3/4 first, right? You could have chosen to get rid of the x over 3. Or you could have chosen to get rid of the negative 1/6 x. Or you could have chosen to get rid of the 5/9. All right. Any of those starts wouldn't be wrong. You would just travel a different path, but if you did everything correctly, you would come up with the same answer that I have. Okay? Now, the other thing to notice is when I multiply by this negative, my sign here changed directions. Did you notice that? So you have to be careful. Keep track of every little detail, because solving inequalities of this this difficulty or with other rational numbers it's the details that kill you. You drop one negative sign when it's supposed to be positive, or it's supposed to be a negative, and you forget the negative and it turns it into a positive, then you've lost it. Everything else down here will become incorrect. We will see you in our next unit.